Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0123 refers to a high voltage condition detected in the throttle position TP sensor A circuit in the Honda CR-V models from 2023 onwards. The TP sensor is a critical component that communicates the position of the throttle plate to the powertrain control module, PCM, allowing it to manage engine performance, fuel efficiency, and emissions. When this sensor records a voltage output higher than a specified threshold, the PCM identifies it as an abnormality, triggering the P0123 code. The sensor is integrated with the throttle body, which can complicate troubleshooting because both parts are connected. Proper functioning of this sensor is essential for the vehicle's throttle response and overall engine behavior. Understanding this error is the first step in diagnosing further and resolving any associated issues in the vehicle. The DTC P0123 primarily involves the throttle position TP sensor A located within the throttle body assembly on the Honda CR-V. The TP sensor's role is to measure the angle of the throttle plate and send this information as a voltage signal to the powertrain control module, PCM. The PCM uses this data to adjust fuel injection and ignition timing for optimal engine performance. As this sensor is integrated within the throttle body, any fault in its circuitry can directly affect vehicle performance. The PCM itself also plays a significant role in this error code by processing voltage signals from the TP sensor A and identifying irregularities. Identifying the physical locations of both the TP sensor and PCM is essential for effective troubleshooting regarding this DTC. The potential causes for DTC P0123 are varied and require careful inspection. One prominent cause could be the TP sensor itself, generating a higher than expected voltage output. Another possibility involves the throttle body being defective, often leading to inaccurate readings from the TP sensor. Wiring issues, particularly in the circuit between the TP sensor and the PCM, may cause open or short circuits that provoke abnormal voltage levels. Lastly, a defective PCM can contribute to misinterpretation of the voltage signals, leading to the erroneous triggering of this code. Understanding these potential causes is crucial for targeted diagnostics and repairs to restore the vehicle's functionality. Symptoms of DTC P0123 can manifest in multiple ways. A prominent sign is the illumination of the check engine light on the vehicle's dashboard, which serves as an initial alert for any abnormalities. Drivers may also experience poor throttle response, where the vehicle does not accelerate as expected when the accelerator pedal is pressed. This condition can significantly impact driving comfort and safety. In addition to these, there could be reduced overall engine performance, making the vehicle feel sluggish. In more severe cases, engine stalling can occur, further complicating vehicle operation. Recognizing these symptoms is vital for quick troubleshooting and repair processes to ensure safety and performance. The first step in troubleshooting DTC P0123 involves turning the vehicle to the on mode without starting the engine. This action allows access to the vehicle's diagnostic systems. Utilizing the Honda Diagnostic System HDS will enable the technician to view the TP sensor A value directly. If this value exceeds 4.8 volts, this confirms the presence of the fault, thereby duplicating the failure scenario. This step serves as an essential check to validate whether the high voltage condition exists and sets the path for further diagnostics. Properly executing this step is critical in identifying the vehicle's needs and understanding whether faulty components are at play. Immediate data obtained from this test informs subsequent actions in the troubleshooting process. In this step, the diagnosis progresses by inspecting the throttle body connector. which is a 6-pin connector that links the throttle body and TP sensor to the vehicle's electrical system. After ensuring the connector is disconnected, technicians should set the ignition mode to IG while measuring the output voltage across the appropriate terminals. Normal conditions would indicate a voltage reading of about 5.0 volts. If this reading falls outside the expected range, it will suggest a problem resides within the throttle body itself. If the voltage is as anticipated, it points towards potential faults elsewhere within the related components. This thorough inspection is vital to diagnosing any issues linked with the actual throttle position sensing. Continuing with the diagnostics, the next step is to perform an open wire inspection of the signaling and ground circuits related to the TP sensor. Specifically, this requires checking the THL1 and SG3 wires for continuity. The vehicle's ignition should be turned off while performing this inspection. A healthy circuit should show less than 1 ohm of resistance between the terminals. If the resistance is above this threshold, it indicates an issue within the circuit connections, likely due to faulty wiring or poor connections. Establishing continuity is crucial since any breaks or shorts can fully compromise the sensor's ability to relay accurate information to the PCM. This step reinforces the overall diagnosis by ensuring each component in the circuit is functional. Once all other components have been inspected and confirmed to be functioning well, the final step in diagnosing DTC P0123 is to analyze the powertrain control module, PCM. Given that it's responsible for interpreting signals from various sensors, any fault in the PCM could lead to misreading the TP sensor's signals. Technicians can diagnose the PCM by assessing for faults prevalent in previously tested components. If everything else checks out, and if the PCM readings continue to disappoint, it is likely that the issue lies within the PCM itself. Ensuring that the PCM performs as expected is critical, since it manages a host of engine functions. Confirming its integrity rounds off an effective troubleshooting sequence. Upon completing all necessary repairs related to DTC P0123, it is essential to verify the effectiveness of those repairs. Initially, any stored diagnostic trouble codes within the PCM must be cleared using the Honda Diagnostic System, HDS. Following this, conducting a test drive is critical to ensure that the vehicle operates according to specifications without re-triggering the DTC. During the test drive, monitoring the vehicle's throttle responsiveness and overall drivability confirms whether the repairs have adequately addressed the radiator problem. If the check engine light does not reappear and vehicle performance is restored, the repairs may be deemed successful. This final verification is vital to ensure the vehicle's reliability and driver safety. To prevent the occurrence of DTC P0123 and ensure the longevity of the throttle position system, maintaining good preventive practices is essential. One key approach involves regularly inspecting electrical connections to the TP sensor and related components. Ensuring these connections are clean and free from corrosion helps maintain signal integrity and prevent voltage anomalies. Additionally, periodic checks of the throttle body for dirt or carbon deposits can preempt any operational failures of the TP sensor. Keeping the throttle body clean supports optimal performance and reduces the risk of diagnostic trouble codes. Adopting such preventive maintenance habits will facilitate early detection of issues, ensuring smooth vehicle operation well into the future. In conclusion, diagnosing DTC P0123 requires a comprehensive understanding of how the throttle position TP sensor operates within the Honda CR-V's engine management system. The relationship between the TP sensor, the throttle body, and the Powertrain Control Module, PCM, is critical for optimal engine performance. Following a systematic troubleshooting approach, including the inspection of all relevant components, circuit integrity, and the PCM, fosters accurate diagnosis and rectification of the fault. Paying attention to the symptoms and validating repairs through test driving ensures that the vehicle is operating correctly. Finally, enforcing preventive maintenance routines will minimize the chances on similar DTCs appearing in the future, safeguarding both vehicle performance and driver confidence. Please like and subscribe to the channel. See you next time.